All right, I mentioned yesterday, right, when we started to foil, that we were also going to factor. We're going to review all of factoring in the next like 4 or 5 days. You guys probably spent weeks and weeks and weeks on it in Algebra 1. We're going to review it quickly here. So what we're going to do today is GCF, greatest common factor. And then we're going to work on some of those special products like difference of perfect squares, the perfect square trinomial. And we're also going to introduce perfect cubes, that pattern. Other than that, like factoring A times C when A is 1, when A is not 1, grouping, that sort of thing, that's going to be after your next test. We'll have a quiz on just factoring, but that'll be after the next test. The only thing on your test as far as factoring is concerned will be anything that we do today. So just be aware of that. There's a whole bunch of different things. But what we're going to talk about today is greatest common factor, GCF. Every single time you factor, because you guys are going to get questions that says factor completely. They're not going to tell you what to do. It's not going to say find the GCF or do this. It's just going to say factor completely. No matter what kind of problem you're looking at, the first thing you should do is take out the what? GCF, the greatest common factor. Sometimes it's a number, sometimes it's a letter, sometimes it's both. But when I look at an example like this, what letter and number do both of these terms have in common? 2x, all right? This is what we need to do, guys. You need to take the 2x and put it out in front. It does not just go away. It is still in your problem. We just move it somewhere else. So some of you like to put the 2x underneath here so you can actually see what you're dividing out. That's fine. But what is 6 divided by 2? 3. And if I have x cubed divided by x, I'm left with x squared minus, what's 4 divided by 2? 2. And then what happens to these x's? They cancel. Your directions are always going to be to factor completely. So make sure once you do, there's nothing else left that you can factor. In this case, there's not. And we'll get to where you're going to take out the GCF and then there's other stuff to do. But in this case, there's not. So these first few examples, we're just going to run through and we're going to factor, taking out the GCF. All right? When we lead with a negative, guys, you want to factor out the negative. Some of you are not going to do that, and then when you leave the negative and then try to factor a trinomial, it's very confusing. So you should always lead. If it leads with a negative, take it out. So when I look at number 1, what number and or letter is in common with all 3 terms? -4. I'm going to divide out a -4 from every single term. So I'm going to write it at the beginning of my parenthesis. It does not just disappear. You can't just write it underneath there and then not include it with your answer. That's wrong. What's a negative divided by a negative? A positive. So I have x. Oh, man. Did this die already? I have x squared. What's 12 divided by -4? -3x. And then what's -16 divided by -4? +4. All right. In this case, we would then say, okay, this is a trinomial. Are there factors of 4 that multiply to give me 4? Positive, but add to give me a -3? No. All right. We're not going to factor past this right now. We're going to get to that after. But you should get in the habit of asking yourself those questions. After you take out the GCF, the result. Is it a perfect square trinomial? Is it a difference of perfect squares? Can I factor it more? Right now you can't, but we're going to get to where we can. All right. Look at the next one. Number 2. What do we have in common? All 3 terms. 3 and an x. Good. So I'm going to bring that 3x out in front, and then I'm going to divide out the 3x. Again, you do not have to write it underneath. I'm just writing it. Some people like to see it like that. So 3 divided by 3 is 1, and x cubed divided by x is x squared. -6 divided by 3, -2, and I have an x. And then 9 divided by 3 is +3, and I have my parenthesis. My x's cancel. Now again, get in the habit of, can I do more? Right now you can't. You're not going to have to. Right now, that's after your next test. But you would say, can I factor it more? And soon you'll be able to. Excuse me. All right, something like 3 and 4. Guys, understand this is one term and this is one term. Terms are separated by plus and minus signs. So with what I have underlined, God bless you, do they have something in common? Yeah, they both have an x minus 2. So I'm going to take the x minus 2 and put it out in front. And then we're going to divide both of these by x minus 2. So do you guys see that this one cancels and you're left with what? 2x. This cancels and you're left with plus 3. The reason you can factor that out is because both of those terms are being multiplied together. If there was a plus sign in there, you couldn't. All right, what's another way, or what could we do here? What do you guys notice? What does the x plus 3 quantity squared mean? How many x plus 3s are here? There's 2. So if you need to write them out, write them out. Minus 4 times x plus 3. Now again, there's 2 terms here. There's a term here, and there's a term here. Again, terms are separated by plus and minus signs. So what do these 2 terms have in common? They both have an x plus 3. So I'm going to take out the x plus 3. I'm going to go ahead and write it under here so I divide. And I'm left with x plus 3, what? What am I left with when I divide this out? Minus 4. Can I do a little simplifying there? Yes, x plus 3 times what? What's 3 minus 4? X minus 1. And there's your problem. If you see something quantity squared and you don't recognize, oh, wait a second, there's 2 of them, go ahead and write it out. So then you can see, oh, in this one, there's an x plus 3, and in this one, they have it in common. I can take it out. All right, so anytime you factor, guys, going forward from now until you're done with Calculus BC, what do we look for first? GCF. Always, always, always GCF. All right, now we're going to get into some of our little special patterns, and you guys are familiar with this. It says when 2 terms of a binomial are perfect squares with a minus sign in between them, please underline that. A minus sign in between them. The only time this works is if the first term and the second term are perfect squares and there's a minus sign in between them. You can square root the first and last terms and have a parenthesis that's 1 plus and 1 minus. Meaning, check this out. Is this the difference of perfect squares? You want to ask yourself that question. What does the word difference mean? Subtraction. Are both terms perfect squares? Yes. What times what gives you x squared? X and x. What times what gives you 4? 2 and 2. There's a minus sign in the middle, so very easily you guys can say, oh, this is x plus 2 and x minus 2. When we factor, what's a really great way to know, yes, I got my question right, no, I didn't? What can I do with x plus 2 and x minus 2? I can FOIL it. And what's going to happen when I FOIL it? I'm going to get x squared minus 4. It's a good way to check because maybe you messed up your signs. Maybe accidentally put 2 minus signs. Then when you FOIL it back together, you're like, wait a second, the middle term didn't cancel like I thought it should. But the only time you can just go ahead and throw that into x plus minus, or x plus and x minus, is if they're both perfect squares and there's a minus sign in the middle. Let's go through a bunch of these, all right? 2 terms. First thing I ask myself, is there a GCF? Is there one? No, 9 doesn't go into 49. All right, so now let's check and see if this is the difference of perfect squares. Is 9x squared a perfect square? Yes. What times what gives you 9x squared? 3x and 3x. Okay. What times what gives you 49? 7 and 7. Is this a minus sign? Yes. So what do my 2 parentheses look like? 3x plus 7, 3x minus 7. Does it matter if the plus goes first, the minus goes second, or vice versa? No. All right. 2 terms. It could be difference of squares. It's a good thing to check for. First thing we ask, is there a? Is there one? No. Okay. 2 terms. Minus sign in the middle. Oh, let's check and see. Is 36x squared a perfect square? Yes. What is it? 6x, 6x. Perfect. What about 49y squared? 7y and 7y. Great. So what are my 2 parentheses? 6x plus 7y, 6x minus 7y. Good. So we don't make a mistake. Because when you factor completely, everything has to be simplified. Is there a GCF here, guys? Yes. What is it? No, the GCF. What's the greatest common factor? There's a 4. If I divide both by 4, what am I left with? X squared minus what? 25. Guys, you have to take the GCF out. If you only took out a 2, it wouldn't be perfect squares. Or if you did this and said it's 2x minus 10 and 2x plus 10. I agree that works, but what do you guys notice about 2 and 10? Is there a common term with 2 and 10? What number can you take out of both of those? A 2, and you'd be left with x minus 5. What can you take out of 2 and 10 in the second parenthesis? A 2, you'd be left with x plus 5. So what does this actually work out to be? 2 times 2 is 4, x minus 5, x plus 5. Take the GC... Okay, so go back here. When we take out the GCF first, that 4 still hangs out in front here. Do I have the difference of perfect squares? Is x squared a perfect square? Yes. Is 25 a perfect square? Yes. Is there a minus sign in the middle? Yes. What are my two parentheses? X plus 5 and x minus 5. Or x minus 5, x plus 5. Good. All right, so the last one. Number 8. GCF. No. Okay. 25 x squared a perfect square? Yep. 5x, 5x. 36 a perfect square? 6 and 6. Is that a minus sign? Can we factor this? No. You guys cannot say that this is, look, some of you are going to say, well, can I say it's 5x plus 6 and 5x plus 6? Well, what happens when you multiply that together? Does the middle term cancel? No, guys. If it's a difference of perfect squares, first and second term have to be perfect squares, but the inside has to be a minus. So here you would just say that's simplified already. Or you could say can't factor or whatever. Do not get fooled by that. You probably will see that. Do not get fooled by that. All right, let's move on to some that are a little more, a little harder. 2 terms? Yes? Okay. Are they perfect squares? What times what will give you x to the 8th? X to the 4th and x to the 4th? Okay. What times what will give you 1? 1 and 1. Is that a minus sign? Yep. So what are my two parentheses? X to the 4th plus 1 and x to the 4th what? Minus 1. Okay. Can I factor any further? Can I do anything with that first parenthesis? Is x to the 4th a perfect square? Yeah. Is 1 a perfect square? Yeah. Is there a minus sign in the middle? On the first one? No. So that one's just going to stay. What about the second one? Is x to the 4th a perfect square, guys? Yes. What times what gives you x to the 4th? X squared and x squared. What times what gives you 1? 1 and 1. Is there a minus sign in the middle of that? Is there a minus sign in the middle there? Yes, so that's the difference of perfect squares. So I can put a plus 1 here and a minus 1. Can I factor any further? Can I do anything with x to the 4th plus 1? No, because it's not the difference of perfect squares. Can I do anything with x squared plus 1? No, it's not the difference of perfect squares. It has to be a minus sign. Can I do anything with x squared minus 1? What does that become? X what? Plus 1 and minus 1. You have to, the hardest thing is going to be when can I stop? So you have to know your rules. The first thing you do is GCF. After GCF, you say, okay, if I have 2 terms, are they both perfect squares and is there a minus sign in the middle? If that is the case, you can break it down. If there's a plus sign, you can't. You need to know that, guys. Super important. You'll get in the habit of seeing this. A lot of times with stuff's raised to the 4th, you can break it down a little more. So let's look at 10. GCF. Is there a greatest common factor between 625 and 1? No, okay. Are these perfect squares? What times what gives you 625? 25 and 25, agreed. And what times what is going to give you x to the 4th? X squared, x squared. What times what gives you 1? 1 and 1, all right? And there's a minus sign in the middle, so I know, oh, wait a second, this is the difference of squares. I'm going to say 25x squared and 1 in both parentheses. And what are the signs in the middle? 1 plus and 1 minus. You have to ask yourself, can I factor more? Is the first parenthesis a difference of perfect squares? No. There's a plus sign in the middle, so you just leave it. 25x squared plus 1. My second parenthesis, guys, is that the difference of perfect squares? Yes, I see a minus sign, so look at your terms. Is 25x squared a perfect square? It sure is. What times what gives you 25? So I have 5x and 5x, right? What times what gives you 1? 1 and 1. And then what are my signs in the middle? Plus and minus. Good job. Anytime you see two terms and a minus sign in the middle, a bell should go off and be like, wait a second, I wonder if it's the difference of perfect squares. And just check. Okay, this one you can do a variety of ways. The way that I'm going to tell you to do it, just to make sure you don't make any mistakes, is to rewrite it in standard form. How would I rewrite that? Tell me. Negative 12x squared, what? Plus 3, all right? First thing we do is take out the GCF. We lead with a negative, so take that negative out. What is the GCF between negative 12 and 3? What is it? Negative 3. We want to take out the negative. So, guys, watch what happens when I take out a negative. Excuse me. What's a negative 12 divided by negative 3? 4, so I have 4x squared. What is 3 divided by negative 3? What kind of 1? Negative 1, right? Look at what you're left with. Two terms? Yes? Minus sign in the middle? Yes. What should we check to see? If it's the difference of perfect squares. Is 4x squared a perfect square? Yes. What times what gives you 4x squared? 2x, 2x, put it at the front. Guys, what times what gives you 1? 1 and 1. Very good. And when we have the difference of perfect squares, do I put the same signs in the middle or different? Perfect. 1 plus 1 minus. Good job. Very good job. Okay, this does not become any harder. It looks different, but it's not any harder. Let's survey the situation. Is there a GCF? No, they don't have a letter or a number in common, but there's two terms. So check the middle sign. Is it a minus? Yes. Okay, so God bless you. Are these two perfect squares? How many x plus 2's do you have? 2. So can I write 1 here and 1 here? What times what's going to give you y? Squared. Y and y. And then what are your signs? Plus and minus. Can you combine anything there? No, just leave it, just like that. But this right here, this quantity squared, means you have how many of them right there? There's 2, so it's a perfect square. As soon as we see just a bunch of letters, we think, oh my gosh, it's too hard, I can't do it. How many more of these do we have? Ay, ay, ay. All right, this one's the same thing. Same thing. Do I have two terms? Yes. Is there a minus sign in the middle? Yes. Are they perfect squares? Yes. How many x minus 1's do I have? 2. So put 1 at the front, 1 at the back. I'm sorry, 1 at the front of each. My bad. And then what times what gives me 9y to the 4th? 3y squared. So 3y squared, 3y squared. And what are my signs? Plus and minus. There's nothing else to combine there. We just leave it. Again, in order to get your signs right, you don't have to, but I think it's in your best interest to do what? How should I rewrite 14? Standard form. Tell me. I hear you. Negative 36x squared plus 81. Great. Is 36 a perfect square? Yeah. Is 81 a perfect square? Yes. Is there a plus sign in the middle?
No.
Yes, there's a plus sign. Do we want it to be a plus sign? No. So let's think about this for a second. What's the first thing you should always look for when you're factoring? Greatest common factor, GCF. Is there a number that goes into both negative 36 and 81? What is it? And what should we take out since it leads with a negative? Negative 9. I'm going to take out that negative 9, and what am I left with? 4x squared, what? What's 81 divided by negative 9? Minus negative 9. Do I now have two terms left with a minus sign in the middle, and those two terms happen to be perfect squares? Yes. So I have negative 9, and I have my two parentheses. What is going at the front of each parenthesis? 2x and 2x. What is going at the back of each parenthesis? 3 and 3. And what are the signs in the middle? Plus and minus. Good job, guys. All right, 15. Two terms? Yes. Minus sign in the middle? Yes. Are each of them perfect squares? God bless you. Yes. What times what gives you x to the fourth? X squared, x squared. What times what gives you 16y squared? 4y and 4y. And what are my signs? Plus and minus. All right. Again, what should you ask yourself? Is there anything else I can do? And the first one, you know you can't because there's a plus sign. My second one has a minus sign and two terms. But are both of those terms perfect squares? No, they're close. X squared is a perfect square. 4 is a perfect square. But is y a perfect square? No. If it was y squared, then yes, you could. So just be careful. They're going to be sneaky. All right, let's go on to perfect square trinomials. Again, we've talked about this before. It's not imperative that you know the formula, but it does help. So I'm going to do all of these with the shortcut so you can see. It says perfect square trinomial test. Square root the first and last terms, then double the product. If the term is the middle term, then it's a perfect square trinomial. What? Okay, first of all, how is this different from the difference of squares? How many numbers are there? There's 3, so you know this isn't the difference of squares. So if we're going to check, and that's what we're going to do in all these, we're going to check to see if it's a perfect square trinomial. Is x squared a perfect square? Yes, x and x, right? Is 25 a perfect square? What is it? 5 and 5. So the way that we check, you take the first term and the second term, and you multiply them together, and you times it by 2. So 5x times 2 is what? 10x. Is that the same as that? Well, in absolute value-wise. Yes, right? So this is a perfect square trinomial. What do you think this tells you should go in your parenthesis? A minus. If it was a plus, then you'd put a what? So your parenthesis is x minus 5 quantity squared. You got 2 of them. That's how you check. You multiply the first times the second times 2. If it's the same as the middle term, then you know that you found what goes in your parenthesis, and whatever sign is with the middle term goes in your parenthesis. Could you write it like this? X minus 5, x minus 5? Yes. If you FOILed that back out, would you get x squared minus 10x plus 25? Yes. Perfect square trinomials are the same binomial 2 times. So let's go through this. Now, again, we're going to get to where we go 16 times 9 and then try to find the factors. Check to see if it's a perfect square trinomial. It's quicker. What times what gives you 16x squared? 4x, 4x. What times what gives you 9? 3 and 3. Okay, let's check. If I take my first term, 4x, I times it by the second term, 3, and then I times it by the number 2. What's 4x times 3 times 2? It gives you 24. Okay. Isn't that what that middle term is? So what does my parenthesis look like? There's a 4x in the front. There's a 3 in the back. And what sign goes in the middle? a plus. And how many of them do I have? So you square it. Get in the habit, always looking for GCF. I'm going quickly, so I know there isn't one, but perfect square trinomial. Let's just see. Not always is it a perfect square trinomial, but it's a good thing to try. 9x squared. What gives me 9x squared? 3x, 3x. What gives me 25? 5 and 5. This is how you guys would show me your work. You would say, okay, first term, 3x, times second term's 5, times 2. What's 3x times 5 times 2? 30x. Is that the number that we got right there? Yep. So what does my parenthesis look like? What goes in the front? 3x. What goes in the back? 5. And what sign goes in the middle? Minus. And how many of them do I have? So we square it. Very good, guys. 18. There's no GCF. So let's just check. What times what gives me 4x squared? 2x, 2x, okay? What times what gives me 1? 1 and 1. So I'm going to take first term times the second term times 2. What does that give me? 4x. Is that what we got right there? Yes. So what does my parenthesis look like? 2x and a 1. And what sign goes in the middle? Plus. And then what do I do to this to say I have two of them? Square it. Good job, guys. The reason why it's good to know the pattern is because when we go to do a problem like this, right? If you guys are going to try to factor this and you didn't know the pattern, you would say 36 times 49, get some ginormous number, then try to figure out the factors of that. That'll multiply to give you 8. That is crazy. When you get big numbers on both ends and they're perfect squares, check to see if it's a perfect square trinomial. What times what gives you 36y squared? 6y and 6y. What times what gives you 49? 7 and 7. So let's check. What is 6y times 7 times 2? It's 84. Isn't that what we're looking for? So what does my parentheses say? 6y in the front, 7 in the back, and what sign in the middle? A plus sign. And how many of those do I have? 2, so I square it. Right? You look at something like number 20, and everything's going well, and then you're like, okay, you used a different letter, and there's 2 of them. Does anything change here, guys? No. Let's check this. What times what gives me 9u squared? 3u and 3u. What times what gives me 16v squared? 4v and 4v. So let's check. 3u, oh, there should be a v here. 3u times 4v times 2. What is 3u times 4v times 2? What's 3 times 4? 12 times 2? 24. Stick a u and a v there. Is that what we have right there? Yes. So what does your parenthesis look like? 3u in the front, 4v in the back. What sign in the middle? Plus. And then we're going to do what? Square it. Okay? Good. Good, good, good. All right. We're going to get through the cubes. I'm going to do 3 examples, and then I'm going to need you guys to finish. Try them over the weekend. You don't have to submit them or anything, but just try them over the weekend. I will include it on the video before I upload it. But you will absolutely have a cube on your test. You have to know this pattern, okay? It's very important. Sometimes you'll see the pattern with U's and V's. Sometimes you'll see the pattern with A's and B's. I'm going to show you both of them, but here's the pattern. If you have 2 perfect cubes and you are adding them, you're going to break it down into this. U plus V, and then it's U squared minus UV plus V squared. There will always be a plus at the end because what happens when you square a number? Becomes positive, okay? If you have the difference of cubes. Oh, I'm sorry. I always use B's. That's what I use on my next slide. Sorry. In my mind, I'm thinking about But I like A's and B's. But the book uses U's and V's, so I'm going to show it both ways. But in my mind, already have it like I did. Sorry. All right, look at my next one. If it's the difference of cubes, what do you think the first parenthesis says? U minus V. Good. You're going to square the first term. And then this is where it gets a little different. You're going to add UV, and then it's plus V squared. So your cubes, whatever the sign is at the beginning, that goes in the first parenthesis. This is a pattern you have to memorize. And this is really easy, guys. I promise. I promise, promise, promise. What you're going to do is you're going to get an example like this, okay? 2 terms. First of all, is there a GCF? No, there's not a GCF. So 2 terms. Is there a minus sign? Yes. Is this the difference of squares? No. This is the difference of what? Cubes. So the first thing you're going to identify is the root. So I'm U. What times what times what gives me x cubed? X. Here's my V. Don't worry about signs. It'll work itself out with the pattern. What times what gives you 125? 5. Now that's all you need. That's all you need to now finish this problem. I'm going to look at the pattern. Is this a U minus or a U plus? So what does my first parenthesis say? X minus 5. Perfect. Then what does the next part say? X squared. X squared plus 5x plus what? That's it. You just have to know the pattern. A lot of times you'll see it with A's and B's. You can use A's and B's. You can use U's and V's. I don't care. I just like A's and B's better. But you have to know the pattern. Again, when you factor completely, they're going to throw something at you and you're going to have to go, okay, is there a GCF? Is it the difference of squares? Is it the difference of cubes? Is it a trinomial? There is a lot we're going to do in the next week and a half. I know it's a review. I know it's been a long time since you've seen it, but there's a ton of practice for factoring that you guys can find on the internet. So let's look at this first one right here. Is this the difference of cubes? Yes. Okay. I'm going to use A and B. I'm going to say A and I'm going to say B. You do not have to worry about signs because the pattern will work itself out. What times what gives you x cubed? X. What times what gives you 27? 3. So your pattern, what is my first parenthesis going to say since this is the difference? X minus 3. Perfect. Now we square the first term, the A term. I write what? X squared. Look at your pattern. What comes next? What sign? Plus. What do I do with A and B? I multiply them, so 3x. And then you square the last term. What's B squared? What's 3 times 3, guys? 9. That's it. If you don't know the pattern, you're sunk. If you don't know the pattern, you're sunk. That's hard. I can get through. Yeah, I can do this. All right. Are these both cubes? Yes. What's my A term? What times what gives me y cubed? Y. What times what gives me 8? 2. You guys will see the numbers start to repeat. So what is my pattern? Is this difference or is this the sum? Sum. So what goes in the first parenthesis? Y plus 2. Perfect. My second parenthesis starts with y squared. This is the only part that's a little tricky. Minus. What do I do with A and B? 2y. And then what do I do with B? U squared. The only thing that's tricky is that first sign in the second parenthesis. All right, let's look at this one. 64 a perfect cube? Yep. Is x cubed a perfect cube? Yep. Is 1 a perfect cube? All right, here we go. So A. What times what gives me 64? 4. What times what gives me x cubed? X. And then my B. What times what gives me 1? Perfect. So is this the difference of cubes or the sum of cubes? Difference. So what does my first parenthesis say? 4x minus 1. All right, here's where you got to be careful with our algebra. What do I do to the first term? I square it. Guys, this is 4x squared. Remember that? What's my next sign? Plus. Good. So now what do I do with a and b? Multiply them. 4x. And then what's my last term? Plus 1. So this is 4x minus 1. What's the first term in my parenthesis? 16x squared. Where did you get 16 from, Olivia? You are correct. You have to square both things. You got to square the coefficient and the variable. And then it's just plus 4x plus 1. All right, last one. I'm going to give you back your quizzes. Are both of these perfect cubes? No. But what is the first thing we should look for every single time we factor? Is there a GCF? Does 3 go into 192? Some of you are like, I don't know. Add up the digits. What's 1 plus 9 plus 2? 12. That means 3 goes into it. So take out that 3. Divide both by 3. You have x cubed plus what? 60 what? 64. Are those cubes? Yes. So what is your A term? X. What is your B term? What times what gives you 64? 4. So that 3 is still there. Don't forget it. It's still a part of our problem. What does my first parenthesis look like since this is the sum of cubes? X plus 4. And then go. What's my second parenthesis?
X squared minus 4x.
Great. Great, great, great. All right, look at these ones, guys. First thing, do you have a GCF? No, we don't. So let's check to see if these are perfect cubes. So my A term, what times what will give me 27? That's going to be 3. What times itself 3 times gives me x cubed? That's x. And my B term will be a 1. So now I'm going to say 3x plus 1 because I have a plus here. Now I'm going to square the first term. 3x squared is going to give me 9x squared minus 3x plus 1. Look here, GCF, no. So let's identify my A term. What times what gives me 64? That's going to be 4. My y cubed is going to be y. And then my B term is going to be 5. We have a minus sign here, so my first parenthesis is going to be 4y minus 5. And then I'm going to square the first term. 4y squared is going to give me 16y squared. I multiply 4 times 5, so I'm going to say plus 20y. And then I square the last term, so plus 25. And then lastly, again, this looks a little different, but it is the difference of cubes. So I'm going to say my A term is x plus 2. My B term is y. This is the difference. So my first parenthesis is going to be x plus 2 minus y. I'm going to square the first term. So when I square, go ahead and say x plus 2 squared. It's going to be x squared plus 2x plus 2x plus 4. So I have x squared plus 4x plus 4. I'm going to multiply these two together. So I have plus xy plus 2y. And then I have plus y squared. Actually, no. And there's nothing here that we can combine that is exactly the same. So it's just going to stay just like that.